Dawn breaks over the naval base, and the sea is still dark enough to reflect the last traces of night. Then a massive gray hull pushes away from the pier, and the sharp bow divides the water as engines build power beneath the deck. There are no passengers waving from balconies here. This vessel lacks cargo containers, holiday lights, or glass promenades. While merchant ships are engineered to maximize cargo volume, and cruise liners prioritize human experience, a warship is designed specifically to fight. Every visible element above the waterline, from the sharply angled superstructure down to the fully enclosed mast, is ruthlessly dictated by that military requirement. For centuries, merchant vessels could be armed and pressed into battle. Today, the modern warship is designed from the keel up as an integrated combat system, distinguishing it from the civilian hulls of the past. This gray hull functions as a mobile projection of sovereign interests, a self-contained network of weapons and sensors capable of exerting force across thousands of miles of open water. The engineering architecture of a military vessel revolves around survivability, the capacity to absorb severe damage, protect the crew, and continue operating in hostile conditions. This resilience begins with redundancy. Every critical mechanical, digital, and power system has an identical backup running in parallel, ready to take over the instant a primary system fails. This diagram shows how that philosophy extends to the physical structure itself through compartmentalization. The hull is divided into a grid of watertight and fire-resistant sections. If one space floods, the bulkheads isolate the damage before it can drag the rest of the ship under. Beneath those bulkheads, the propulsion system also splits its duties. A combined diesel and gas setup, or CODAG, relies on diesel engines for efficient, long-range cruising, while massive gas turbines stand by to deliver extreme sprint speed when required. Above the water, the focus shifts from absorbing damage to avoiding it altogether. Modern stealth geometry utilizes inward-angled surfaces and fully enclosed equipment to deceive enemy sensors. The goal is to reduce the ship's radar cross-section. While a traditional flat hull bounces radar energy straight back to the enemy, an angled stealth surface reflects that wave harmlessly away into empty air. On an enemy screen, a massive destroyer can appear as tiny as a fishing boat. Inside this stealthy shell sits the digital brain of the vessel. Systems like the Aegis combat network synthesize radar, computers, and sensors to project a continuous, invisible defensive dome over the surrounding ocean. The physical manifestation of that network is the vertical launch system. Built flush into the deck is a grid of missile cells capable of intercepting incoming aircraft, striking inland targets, and launching anti-submarine rockets. Modern engineering prioritizes geometry and digital networks to intercept threats at a distance, replacing the heavy steel plating of previous naval generations. Naval supremacy cannot be achieved by a single hull. As we see in this aerial view of the naval base, a modern fleet is a specialized hierarchy of interacting vessels, each engineered to cover the blind spots of the others. The closest ring of defense is the green water perimeter. This coastal zone is actively protected by smaller, highly maneuverable patrol vessels and corvettes. Moving into open water requires larger escorts. Frigates are primarily tasked with detecting and hunting enemy submarines, while heavily armed guided missile destroyers, like the DDG-51 seen here, provide wide-radius air defense. Escorts exist largely to protect the apex of surface power, the supercarrier. Displacing roughly 100,000 tons, ships like the CVN-78 act as sovereign, mobile air bases. The carrier itself doesn't launch missiles at the enemy. Its true payload is its embarked air wing, a fleet of fighters and support aircraft that can project strike capability hundreds of miles beyond the horizon. Carriers rely on different methods to launch those heavily loaded aircraft. While some use electromagnetic catapults, designs like India's INS Vikrant utilize a distinct ski jump ramp on the bow to assist short takeoffs. Other carriers operate advanced fighters utilizing short takeoff and vertical landing capabilities. By redirecting thrust downward, aircraft like this F-35B can safely operate from much smaller flight decks. Below the surface lies an entirely hidden dimension of naval architecture. Submarines sacrifice speed and visibility to hunt targets in silence, with massive nuclear-powered variants forming the ultimate sea-based leg of nuclear deterrence. True force projection relies on this taxonomy. The vulnerabilities of a carrier are covered by the anti-aircraft radar of a destroyer, whose underwater blind spots are guarded by a frigate. It is an interconnected mechanical ecosystem. Regardless of stealth or firepower, a fleet faces one inescapable limit. Its global reach is strictly dictated by its ability to remain at sea without returning to port for supplies. Overcoming that limit requires underway replenishment. Transferring fuel and ammunition between massive steel ships while moving side by side in open ocean is the most vital and dangerous operational maneuver a Navy executes. During a connected replenishment, tensioned cables called high lines are passed across the gap. Heavy fuel hoses and high explosive ammunition are suspended directly over the rushing water. The most immediate threat is invisible hydrodynamic suction. When two hulls move in parallel, a pressure drop pulls them violently together. To prevent collision, helmsmen must apply outward counter-rudder forces, driving slightly away from each other to maintain a straight path. To speed up this process, helicopters simultaneously perform vertical replenishment, ferrying critical supplies straight down onto the moving flight decks. A multi-billion-dollar carrier strike group is ultimately dependent on these highly coordinated logistical supply lines. The combat environment exposes every flaw in a ship's architecture, electronics, and crew doctrine. The modern threat environment leaves almost no room for error. Anti-ship missiles skim just above the wave tops to evade radar, and hypersonic weapons traveling at 5 times the speed of sound compress a ship's reaction window down to seconds. During the 1982 Falklands War, HMS Sheffield was struck by an Exocet anti-ship missile. The initial explosion crippled systems, but the subsequent spread of fire and toxic smoke through damaged compartments proved the actual cause of the ship's loss, overwhelming the crew. This is why damage control is an absolute all-hands requirement. If the hull is breached, every cook, radar operator, and mechanic must instantly become a firefighter, shoring up bulkheads in total darkness. Below the waves, submarine warfare is a contest of hunter and hunted. Here, making a single mechanical noise can result in immediate destruction. Advanced sensor networks and automated defenses are useless if exhausted human beings cannot make the correct decisions under stress to keep the ocean out of the hull. That critical human element is tested constantly. A standard deployment lasts 6 to 9 months, requiring intense psychological endurance to live and work inside these confined, artificially lit steel corridors. Yet this vast machinery serves a specific purpose. When a warship appears on the horizon, its presence alone acts as a direct political signal and a visible, undeniable national commitment. Back at the naval base, the pier returns to quiet. The wake fades and the fleet vanishes over the horizon to hold those distant lines. But at the adjacent berth, a completely different vessel waits. Painted bright orange and white, its massive rear deck is crowded with heavy industrial infrastructure. It carries no missiles or aircraft. Instead, it features towering cranes, massive subsea cable reels, heavy winches, and working platforms built for absolute utility. Beneath the waterline, a computer-controlled system relies on arrays of multi-directional thrusters to hover the ship over an exact coordinate, locked in place despite heavy ocean currents, without dropping an anchor. We are leaving the world of warships built to fight. In the next episode, we enter the environment of specialized offshore vessels, the machines built to construct and sustain the modern ocean economy.